Hi everyone, in this video we're looking at Venn diagrams and possibly some of the CSEC multiple choice questions on sets on the whole. Just a disclaimer, I apologize in advance if there are any construction noises in and between. I apologize for that. Okay, so let's start. So a Venn diagram is essentially, we have a rectangle. The rectangle represents the universal set, meaning the main set. And inside we have our sets inside, right? Now, this first set I'm showing you all here, this Venn diagram actually represents two disjoint sets. Disjoint sets meaning they don't have anything in common. So they don't overlap at any point. It's just two separate sets inside the Venn diagram, right? So here we have set A and then we have separately set B, and they're all enclosed by the rectangle, which is the universal set. Now, let's look at the other one down here. So, this Venn diagram here below have two sets that overlap. That portion where they overlap represents what they have in common, or we learned in our previous video, A intersects B, that intersection. So this here is our intersection, that is A intersects B, and the second diagram shows it here, right? So where they overlap, so I'll draw it again, where they overlap, that is the intersection there, right? So sometimes you would have two sets that overlap. Sorry for my poor drawing. Set B and set A. And let's say they have 1 and 2 in common. So you put numbers 1 and 2 in there, right? It's kind of like that, right? So the shaded region in these Venn diagrams here represents A intersect B. So let's look at some more Venn diagrams now. So, in this one here, A and B are shaded. So again, I apologize for the construction noises. So yes, in this Venn diagram, both sets A and B are shaded. So this Venn diagram represents A union B, because both sets A and B are shaded. Let's get the Venn diagram down here now. In this Venn diagram, everything is shaded but set A and set B. You'll see now everything outside but set A and set B are shaded. So this is A union B, the complement of A union B. Remember, we learned that as well in the previous video. And let's look at this one down here. And this one here, this is a popular question that sometimes comes in the multiple choice. Everything is shaded but set B. You're seeing how set B is just everything else is shaded on the outside, right? So this is really B complement. Everything is shaded but set B, right? If I had a Venn diagram with set A and set B, and everything, let's say this is A, this is B, let's say everything is shaded but set A. And my diagram is very poor, but let's say everything is shaded but set A. This would be A complement, right? Similar to what we have here with B complement. So we're starting the CSEC multiple choice questions. This one here I'm actually going through with you first. So here we have a rule to remember. We have, this rule says the number of members in A union B is equal to the members in A plus the number of members in B minus the intersection of the number of members in A intersect B, right? So let's look at this question in particular here. I'll just increase the size a little bit so you can see it. So now what it says is that if P and Q are sets where we have the number in P union Q is 13, the number of elements in the P intersect Q is 6, and the number of elements in set Q. Using the formula, right? Again, it's all you need to remember is the union, the number of the members in the union is equal to number of members in the two single sets minus the intersection. So we're just going to put in the values here. So the number of members in P union Q is 13. That is equal to the number of members in P, which is 9, plus the number of members in Q, which we want to find, minus the number of members in the intersection, which is 6, right? And then it's like kind of like solving like a algebraic question, right? So we get, I'll write it down here. So now we have 13 is equal to, I put the 9 and then the minus 6 together plus the number of members in Q. 3 plus the number of members in Q. And we're just going to make the number of members in Q the subject. We want to find how much that is. So it's really 13 minus 3, which is 10. 10 members in the in set Q, right? So again, this formula here is very, very important to remember, right? So just make note of that. So we're going to try these 3 questions which uses the formula. So in this first one, I'll call this number 1, number 2, and number 3 down here. In number 1, the number of elements in set A is 14, the number of elements in set B is 15, the number of elements in intersection is 6. We want to find the number of elements in A union B. So again, using the formula, right? So it's union is equal to the 2 sets separately. And it should just take out this line, so I get some space, right? And then minus the number of members in the intersection. So minus, right? So now we want to find this, right? The number of members in A union B. So now for the number of members in A is 14 plus the number of members in B is 15. And then we minus the intersection number, which is 6. So we are going to get 14 plus 15, which just give us 29 minus 6. So we get 23. The answer is C. Let's look at number 2. In a class of 32 students, 17 study music. So the number that study music is 17. The number that study art is 20. And now that 32 really represents what? The number in M union, music union art, right? So you want to find how many study both, right? So again, we write down our formula, right? The union minus the 2 sets individually, you add them individually first, and then you minus the intersection, which is what we want to find, right? The intersection. So we're going to get the union, number of members in the union is 32. That is equal to the number of members in music, which would be 17, plus the number of members in art, which is 20, minus that intersection, right? Oops, I left out the intersection sign. So this is really 32. 32 is equal to 37, right? So I keep on leaving out that intersection sign. Don't leave it out. Right. So essentially our answer will be, for the intersection, 37 minus 32, question that comes B, right? And then number 3, again, is similar thing here. They want to find, just like number 2, the number of members in the intersection. So I'm just going to write the formula one time. Number of members in P, the union, is equal to the number of members at each set, the addition of each set separately, minus that intersection, right? So I start putting in our values. Union is 10, P is 5, plus Q 9, minus that intersection. Get 10 is equal to, this is 14, minus the number of members in the intersection. So essentially, with the intersection value would be 14 minus 10, which is 4, right? A is 4. So again, similar questions, these questions, they come. And as I said, sets come in multiple choice only, so it's good to really go through these multiple choice questions over and over. All right, some lighter questions. Let me just number them, 5. We could call this 6, since this one was already named 7, right? Cool. So number 4, we have set P, Q, and S. Then we want to find the intersection. Remember that symbol means intersect. The intersection of all 3 sets. What do all 3 sets have? Well, clearly they have 2 in common. So this one is pretty easy. The answer is E. Number 5. So set M is equal to PQR. Set N is equal to PQ. Which of the following statements is true? right? Now, looking carefully, if you look at set N, the members of set N, all the members of set N, meaning P and Q, are part of set M. Remember what that, does anyone remember what that means? So N is a subset of M, but there's no option here saying that this is really saying N is a subset of M, but there's no option with that here. A is saying that M is a subset of N, and that is not true. This is not true. All right. M union N. So if they say the union of the two sets, it's going to give me back set N, but that's not true as well. M union, and if we had to write it out, would be P, Q, and R, which is not set N, so that's wrong as well. Then they're saying M intersect N is an empty set. But if we look at M intersect N, what do they have in common? P and Q. So therefore this one is wrong as well. Right? Now, D is correct because M intersects N is PQ, which is really set N. Right? Again, all the popular questions, right? All right, let's look at number 6. Which of the following sets is empty? P is prime numbers, Q are odd numbers, R is sets of even numbers. Now, what you should know is that, look at the options. P intersect R, Q intersect R, P intersect Q, and P union Q. If you look at B is the answer, and I'm going right away because why? Q intersect R. That is telling us that Q and R, right? Q are odd numbers, R even numbers. There are no odd numbers and even numbers that are in common. So therefore, this will give us an empty set because there's nothing in common with set Q and set R, right? So the answer is B. Which of the following sets is empty? Q intersect R. All right, number 9 and 10. Let's see if we get this done quickly. Number 9 and 10 refer to the following Venn diagram. We have two sets, T and C, represent students who play tennis and chess. How many students play both games? Remember, both is the intersection, right? And clearly C is inside of T. So clearly inside here is how many students play both, which is 2. Number 10, how many students play exactly one game? Exactly one game would mean these children, Alex, Tom, Kayla, Ali, they are not part of the intersection, which means they play tennis only. So that means 4 students play exactly one game. And now let's look at number 11. Question just like what we did a little bit earlier. In this Venn diagram, the shaded region represents everything is shaded but P. So therefore this is A, P complement. And then number 12, easy one as well. In the following Venn diagrams, what is the region A intersect B complement? Right? Now, B complement, first of all, is what? If I have 2 sets, B complement would be all of this. Everything shaded but B. Right? Everything is shaded. And if I had to shade A, this is A. So what is the intersection? What do they have in common? The only part shaded have in common in both, right? Let me just use a different color. In both diagrams, what they have shaded in common is this piece here, if you realize. Just A only. No intersection, which is really answer B, right? And then last one, number 13, the number of students in each set shown. We have universal set, how many play hockey, how many play volleyball. How many students do not play volleyball? Well, clearly this 3 here don't play volleyball, and this 5 in the hockey don't play volleyball. Because remember, this 2 represents the intersection who play both volleyball and hockey, and this is how many play volleyball only. So it's really 5 plus 3, which is 8 students do not play volleyball. So that is at the end. This is the end of sets. Go through all the videos. There's nothing more ready because it's just multiple choice for CSEC, as I said. And that's it. So see you all in my next video.